Welcome to lesson 4.5, Composing Reflections over Intersecting Lines. Now, in our last lesson, we learned that a composite is basically resulting from a series or multiple reflections. So in this case, composing reflections over intersecting lines. Last one was dealing with parallel lines. So now we're looking at doing a series of reflections over lines that intersect. And when we do that, our resulting image and that resulting translation that we do creates a rotation. So if you're doing multiple reflections over intersecting lines, all that it's ending up doing is creating a rotation. So a rotation is a composite of two reflections over intersecting lines. Our rotations preserve the following. Rotations preserve angle measure. They preserve point betweenness. They preserve collinearity. They preserve distance between points. And they keep the same orientation. So our reflection, the original reflection, we know orientation gets reversed. When we're doing a rotation, that orientation is still the same. So if your first pre-image is clockwise, your final image after the two reflections is also clockwise. So in example 1, it asks us to describe the rotation that maps triangle ABC onto triangle A prime, B prime, C prime. Well, you can tell my image doesn't match up with that because it's triangle XYZ and X prime, Y prime, Z prime. Same concept. So we're going to describe the rotation of triangle X prime, Y prime, Z prime. What rotation maps that into this location of X prime, Y prime, Z prime? And we are rotating about point A. So if we have point A here, what you want to do is draw segments if they're not provided, starting at A. So I'd draw rays, starting at A through one point and its corresponding point on the other figure. So if I go A through Y, then I have to go A through Y prime. If I did A through Z, then I'd have to go A through Z prime. By doing so, you give yourself the angle that you can measure. So you would set the protractor center here, set the bottom along this side, and measure this angle. That angle measures approximately 102 degrees. Now remember, with rotations, we have magnitudes. If you are rotating clockwise, you have a negative. If you are rotating counterclockwise, it's a positive. Well, from here to here, that went clockwise. So from here to here, clockwise rotation, so my magnitude has to be negative. So that rotated a negative 102 degrees and has a center point at point A. So the rotation had a magnitude of a negative 102 degrees and a center of point A. Now, we do have a theorem to go with this, of course, and it's the two reflection theorem for rotations. So this theorem states, if M intersects L, the rotation RM composite RL, so that would be the rotation, so if M intersects L, the rotation, reflection M, composite reflection L. So the lowercase r's here stand for reflection still. So this would be reflecting over M following a reflection over L. That tells us it has a center at the point where lines M and L intersect, and the magnitude is always twice the measure of the angle formed by these lines in the direction from L to M. So that direction would be going from line L to line M to figure out if it's positive or negative. Because the first reflection is over L, then reflecting over M. So the magnitude is twice that measure of an angle formed by lines L and M, and then the direction would be from line L to M. So we're going to look at an example using that theorem. So example 2 says describe the center and the measure of an angle to determine the magnitude of the rotation RQ following RE, or composite RE. So that would be reflecting over E, then reflecting over Q. So first thing that we could look at is we know the center points where the two cross. So our center point would be point M. So the center is point M where the two lines intersect. We know the angle measure here is 114. So I also know this is 114 down here. Well, 114 and the missing angle are a linear pair. So if this is 114, 180 minus 114 gives me the 66 for this angle, which also means this one here is 66 because they're vertical angles. So now I have the 114 here, the 66 here, 114 here, 66 here. So now we need to finish our description. We knew the center was M, and I know my angle measures. So what we need to look at is that magnitude, and if we are going, looking back, RM following RL, that means our direction is from L to M. So if we're RQ following RE, we're looking the direction from line E to line Q. So if we're going E to Q, that would give us the direction. So now, we could look at this having two different magnitudes depending where it started though. So in one location, we could say from E to Q would be 66 degrees. From E to Q right here, it's 66 degrees. So doubling that would give us 132 degrees. And the rotation direction from E to Q is clockwise, so that would be a magnitude doubling 66 and clockwise of a negative 132 degrees. Or on the flip side, E to Q here is 114. So there's an angle measure also in between E to Q, that's 114, but that direction is counterclockwise from E to Q. So in that case, the magnitude of that rotation would be doubled 114, 228, going counterclockwise, so that'd be positive. Both of these answers would be acceptable. You could have a magnitude of a negative 132 if you're looking at it going E to Q this way, or if you started here and then reflected over to here, you could also look at that as a positive magnitude going counterclockwise, giving you 228. Both of these are correct answers. So if I had a point here, reflected over E, then over Q, or if I had a point here, reflected over E, then over Q. So example 3 tells us A double prime, B double prime, C double prime is the image of ABC under a rotation about point Z. Using a protractor and a straight edge, create two lines M and N such that, and now they're giving us a different notation, not composite notation. So this notation though would be ABC reflected over M and then reflected over N. So if we're going to reflect ABC first over M, then over N to give us A double prime, B double prime, C double prime. So the first thing you want to do is draw and measure angle CZ double prime, or AZA double prime, or BZB double prime. So we want an angle where the vertex is at our center point of Z, and starting from Z, draw a ray through corresponding parts. So on mine, I drew mine from Z through C and C double prime. We want to measure that, which would be 140 degrees. So that's the first start of that process. Then the second part tells me that the angle measure between the two lines will be half of that. So if the measure between the two images is 140, we're looking at this theorem backward. So if the angle measure between the first and final image is 140, half of that would be the angle measure between my two lines. So the angle measures between lines M and N would have to be 70 degrees. So that third and final step is to draw the two lines through Z that meet at 70 degrees, and then you label them M and N so that M to N would be clockwise. So in this case, to get line here and line here, what we ended up doing is we first drew in that first angle, measured that, 140, cut that in half to give me 70. Then it doesn't matter really how we draw our first line, so I would just draw in line M through Z. So I drew in line M through Z. Now to get line N, I would mark a 70-degree angle centered at Z, bottom at M, put a point out here for the 70 degrees, and then draw a line through that point in Z to create line N, giving you your 70-degree angle. And when you label them M and N, you want to make sure that you're going clockwise from M down to N, or from here to here, that's clockwise. So then here down to here, here to here, here to here, and so on. So in this case, our 70-degree angle would be M to N. So if I were to properly label these two lines, if we were going to properly label these two lines, it would have to be based on where the 70-degree measure is. So if I wanted to be 70-degree measure M to N, this line here would be line M. This line here would be line N. So this one would be N, this one would be M, because then M to N is clockwise 70 degrees, and then we'd have that double measure.